from the technical campus. So in industrial building already we have completed 80% of work because the design of following is already covered in design of tension member, compression member, we have covered last practicals and how to find the member internal forces of members while knowing the external forces on the truss. That also we have completed, and based on that you have designed the rafter, that is compression member of truss, strut, that is also the compression member of truss, tie member, bottom tie, it is the tension loading also we have done, and ceiling main tie I go on to you, that is tension member you have design. So due to the wind load, the reversal effect may be happening on the truss. That's why we have designed the tension member for tension and check for the compression. Similarly, for compression member of truss, we have designed uh, for compression and check for tension. So all these things we have already completed. Okay. So once again, I will just briefly go through that. That is practical on 8th October. You complete the design of rafter and design of bottom tie. Okay, so for that we have taken the design load from our force table, and then if the compression member is there, then we have to find out the design strength of your compression member, and that should be greater than the load coming on that member. That load coming on the member is okay, then you can say that it is safe in compression. Then we have check for the same member for the reversal weight, the tension. The tension in the member is 65.14 kilonewton, and then we have check for the TDG, TDL, and based on that, the, the values are greater than 65.14 member, then we say that the after intention also say whatever we have assigned the dimension to the member. Okay, so my voice is clear to you? I think so.
Yes,
If
sir.
if there is any problem or any issue, you can contact me or inform me. Huh? So my health is not good, that's why maybe some problem. Design of bottom tie also we have completed. The worst combination is coming on the L0, L1 and L7, L8 numbers. For that also we have written the tension, maximum tension and compression on that member because the bottom tie in gravity loading, that is tension member, that's why the value of tension is small, you can see here, and the value of compression is small, you can see here. Okay. Then we have initial sizing of the member based on the TDL, and then find out the TDG, TDL, and TD, that is in both the TDG and TDL. And that value should be greater than your test. Then check for the comparison for the same member you selected. That you have to find out PD is equal to AG into FCD. So you have to find out the FCD by using table number 9C, because any member of uh, tension member that is in angle, there that is the buckling class, uh, sorry, any member of angle section in buckling class C. That's why we are using table number 9C to find out the FCD. And if you know the FCD, you just put the gross area into FCD, you will get the PD, and that value should be greater than the compression load on that member. If it is okay, then we can say that our design is safe. Our design is safe. Okay. So this we have done in 8th of October. Then second we have done this another part of your design, the design of the strut. The strut is nothing but again you can say that is a compression member of truss. So how to design the I have given you the first of all the steps for design of the compression member in case of the stress. Then we find out the area required and initial sizing of the member is done. And then you have to find out the FCD using the empirical value. After deciding the member size or type of member, okay? Then you have to find out the FCD by empirical equations. Find out lambda V, lambda phi, lambda E, that is equal to cylinder ratio. Then phi you have to find out their FCD is equal to under root Fy1 and 0.5% under root pi square minus lambda is beta value. You can get the FCD. Kg into FCD is nothing but again the design composition state of member. Let's find out. Load on that member is coming, it can be take or design strength of member is 50.91. That is much larger than 15 kilometers. Okay. Then that same section is check for the tension because it's compression member. So you have to find out TD. TD is the minimum TDG, TDN and TDB1 and TDB2. So cross section ending, net section rupture, strain you will find out. Based on these formulas, I have covered this and then find out the block shear failure. That pattern you have to draw for the black shear failure first and then write the values and then find out the AVG, ATG, gross shear area, gross tension area, net shear area, net tension area. Based on that you can find out TDB and TDB2. In all the four values, you can see that TD is 94.03 km. That is much less, and it is much greater than the tension coming on your work. But that is 30 kN. It means that our chosen section, that is the ISA 65 by 5, is also safe in tension. And then I told you similarly you have to design the tension member that is steering I mean length 2.5 meter for the vertical member, vertical tie from the truss. So that you have to do on your own. So till now we have completed we have up till now we have completed. So I will write down this is lab lecture number I think so 18 for practical I think so lab DSS and today is 16 October 21. Okay. So up to now industrial building many parts we have covered. Line of industrial building. Line of industrial building. Industrial building. That is mini project 1. This mini project 1. In that case, first we have done the initial functional planning of industrial building, functional planning of industrial building. Okay, then we have done selection of food truss, that is selection of type of roofing system. Okay, and then we We have done the load calculations due to dead load, due to lie load. This is dead calculation. You can say the external load also, yeah, external load. Dead load, lie load, and third is wind load. So if you do the load calculation externally, then we have drawn the uh, we have drawn the find out the find out we have find out the internal forces in the member, internal forces in the member, in the member. Similarly, that is also due to due to dead load, due to lie load or force load, or due to wind load. Okay. Then after completion, we have made force table, force table for internal load on the on the member of truss, member of trusses. So that we have completed, and based on this load, we have calculated worst combination of loading by putting certain partial safety of factor, partial safety factors as per IS 800 2007. So based on that, we have calculated the worst combination of loads, and then from the combination of loading, selected worst loading member, loading members, that is for for after, that is tie member. Yeah, sometimes it is called a bottom tie, and then strut, and then ceiling, that is vertical. The worst combination we have completed this, and then based on that, we have design of design of rafter, tie member, strut, and ceiling. Up to till this we have done. Now we have to find out load on columns and design of column subjected to axial load and moment. Axial load and moment. This is remain. This what you are writing now. This is remain. Okay. Yes. Inshallah run today. Then you have to design. This is also balanced. This is not done. This is not done. Design of gantry girder, gantry girder in industrial building. So this we will cover. This we will cover in classroom lecture. Okay. Or let we will see. Possible we will take in practical class. Possible, if possible. What's time moving month? Hello. What is time moving a month? Possible. We will design that. We will design in practical class, if possible. Okay. Also, what you are balance load and design of column and gantry cutter and design of column base for industrial building. For industrial building. So all this work, if you complete, then only your design will complete. So this functional planning we have finished. Roofing system we have finished. Load calculation, external load calculation we have finished. Internal forces also we have find out for industrial building, that is also finished. Okay. Force table for the worst combination loading, that is also completed. Then design of member of truss is also completed. Okay. And now design of rafter, timing or strut and ceiling is completed. This is over. Now it is balanced load and design of column. This is balanced. Now design of gantry girder. This is balanced. And the tail design of column base. So first of all, you have to understand, so what is balance. Balance work uh, till now for industrial building or design of gantry girder, design of column with movement, and design of column basis. Column basis. ये हमारा काम इतना बाकी है. This is nothing but a balance work you have to do. This balance work you have to do. And also in that, the design of column or axial or bending moment already covered in unit number 3. Design of column bases, it is covered in unit number 3 as well. And design of gantry girder, it will be on unit number will be on the unit number, wait a moment. engine. It may be uh, unit number 5. Unit number 5. This part is not covered in classroom. Because now we are running on unit number 4. After that, we will start this. So this gantry girder and you have balance work. So after your examination will start, after your examination, after your insane will start this gantry girder design, practical hours, and plate girder design. We'll start at and based on that you have to find out you have to complete your full work. And this plate girder design the part of mini project 2. So mini project 2 is nothing but plate girder design. Plate girder design. Okay, and then you have to remain two site visits. If physical class open, then we will visit. Okay. This one. So up to this part we have to complete. Okay. So you can how to calculate loads on column. Just I will say you and then we will stop here because what the if you see here, this is the column. This is your column. Okay. It may be built-up column system. You will design lacing system or backing system. This is your column. Okay. The column. This one is the column base. One is column base. And then your column will rest on the foundation. Okay. The column will rest on the foundation. So how to calculate the loading? You know that the loading will be this reaction from the truss, reaction from truss, where I the load on the column, load on the column, on the column. Okay. So reaction from the truss first load, then axial load and moment, axial load and moment due to gantry girder. So if you are providing the gantry girder, if you are providing the gantry girder like this is your bracket, and over a bracket your gantry girder is pressed. Okay, your gantry girder will rest like this. This is gantry girder. So load of the gantry girder, that is it is having a eccentricity. So that's it. Moment also generate on the gantry girder. So load, actual load of gantry girder is added, And the moment also we are doing, and moment you know that how to calculate load into eccentricity. Okay, so this is, if this is eccentricity, then you have to find out the moment. Okay, then you have to find out the moment. The axial load and moment also. So if one direction moment is there, then you have to design the column in uniaxial bending. Uniaxial bending. You have designed this column for uniaxial bending. एक तो ये लोड आ गया, लोड फ्रॉम द ट्रस, I will kind of PT or can get a PG, and then load from the bracings. We are providing the bracings for side sitting. So from the bracing, these are the beams, bracings. So third load will be on column is a load from bracings. उसके बाद load of side seating, If you include in load and bracing the side seating, then no need of adding extra. And also self weight of your column. So all these load will come at the footing, at the base of your column. That load, you have to design all these loads for the column, and there may be some eccentricity or eccentricity moment is there on the column. So you design the column by considering all these loads, and that load you can calculate. First, you have to find out the load reaction from the truss, that is PT. Then axial load and moment due to the gantry girder, load from the bracings, load from the side sheeting, and self leg of column. If any other load are there, then you have to incorporate. If any other loading is there, then that also we have to add. Okay. So like as you have to design the, calculate the load on the column and then design, and then the same load, for the same load of column, you have to design the column basis. Because moment is also there, then we are going for the gusseted base. Gusseted base. Go for the gusseted base and design the gusseted base for the column basis. Only the part will remain the design of gantry girder, and this we will start after insert. Okay, so that's all today. So yeah, I'm not taking much time of you to study, because from next week, you have the workshop for design of your RCC structure. I will request all the students can join that workshop. For 5-day workshop is only, and join that online workshop, and that is very beneficial for you. Will get the good certification, and that will be work. So I request all the students they should join the workshop. Very minimum fees is there, only 300 for 5 days. It is very minimum. Go for that. That is on virtual mode, no physical class, no physical appearance. In case if you don't have a computer, then the department will arrange you place in the computer lab. So would request all of you, please join the workshop and get benefited. Okay? If you have any question, you can ask with me or we will stop. And today you will do your own calculation on design of column and column basis. Calculate the design load for the column, factored load. Already factored out plus we have done, so that factor load coming on the plus. And then gantry cutter load, how much gantry, how much ton of the your gantry you are selecting, based on that you calculate the load. And weight from the bracings, all decided on the column. And the moment is also coming on the column, then you have to design the column with axial load and moment. And that is today's your. And after design of column, you have to design the gusseted base also for your industry. And then your industrial building will finish. Only the remaining part will be the gantry loader design. Okay, so we will stop here. So if you have any query, you can ask with me. Otherwise, we will stop. I'm thinking that the students they are not taking serious. Very few students are joining and then giving back. I'm not.
हेलो
बोलिए।
सर मेरा वो हो गया है क्या बोलते हैं अपना खाली मेंबर ऑफ ट्रस्ट निकालने का बाकी है सर मेरा डिजाइन लोड के लिए
इंटरनल प्रोसेस तुमने निकाला ना?
हाँ सर सब निकाला सिर्फ डिजाइन लोड के लिए वो मेंबर ट्रस्ट निकालने का बाकी है।
अच्छा अच्छा
हाँ
ठीक है, उसमें कोई दिक्कत आ रहा है आपको?
नहीं सर अभी निकाल रहा हूँ दिक्कत आने के बाद एसएमएस कर दूंगा।
तो कोई प्रॉब्लम है तो you can ask with me.
Yes,
Otherwise, continue your work. You are doing very well. Thank you. And
yes
you
sir,
are
thank
you are the role model for the whole class in Kerala. You are doing very well. Most of the
yes sir,
students they are not taking seriously. They will lose because this time the external will come for their oral. No internal examiner will give the marks. They are thinking that कि पहले जैसे चलेगा लॉकडाउन में ऐसे चलता रहेगा. That will not happen. You have to study good. You have to make good presentation. There is no online examination. You have to submit physically your work. You have to show your work in front of faculties and then explain each and every part of your sheet, your mini project 1, your mini project 2, and 2 side visit reports. All this work given you complete, then you will get the good marks. Otherwise, you will lose the marks. ठीक है, कोई क्वेश्चन है बेटा? Otherwise, we will stop and I will take the feedback for all the students about their work. Thank you for joining.
thank you sir।
Welcome.